Okay, so you first analyze that is A equals to B here. Now let's check B equals to C here. Okay, very important term that we have to define here. So B equals to C. छोटी सी term है, छोटी सी बात आपके इसमें समझ लेते हैं क्या है क्या आपका इसमें. So in this case, when I'm saying there is T by IP equals to G theta by L. Now here, first of all, I will introduce or I will define it a one term here before going to the main term. So I'm saying theta. So for the theta, you can write this is TL by IPG. Okay, theta I'm saying TL by IPG here. In this case, obviously I defined that is theta is the angle of twist. Angle of twist. So what is the sense of this term? What is the angle of twist here? So let's suppose you have a rubber shaft and you have a steel shaft. So I think you can easily twist the rubber shaft. Okay. So means the rubber shaft is not that much rigid compared to the steel. Steel is more rigid. Okay. Because in that case you require more torque to twist the shaft here. So obviously in this case the angle of twist that we are defining here, this is the induced one and depending on these criteria. Okay. So when we are trying to say the angle of twist, ठीक है जब हम बात करें आपके पास में angle of twist की theta. So this is a theta induced and this is TL by IPG here. And obviously for a particular material, there is a limiting value of angle of twist. After that, the shaft is going to crack. Okay. Or there is a permanent yield in that shaft here. So means for the safety purpose, this must be less than or at least equals to, or means an extreme criteria equals to the theta permissible for the shaft here. Okay, so here we are dealing with this term, there is a angle of twist here and this is completely depending on this criteria. So who will decide this one? ठीक है, इसको decide कौन करेगा कि आपके पास में इसकी value कैसे रखी जाए? So now in this case I will define a term here, that is this one. Okay, that is GIP. GIP here. Okay, in the last case I think I already defined. ठीक है, जब हम बात करते हैं आपके पास में bending equation की, तब भी हमने आपके पास में एक टर्म डिफाइन की थी, दैट इज द जो हमने बात की थी उसको दैट इज द आई थिंक सॉरी दिस इज मुझे याद नहीं आ रहा आपके फ्लेक्सुरल रिजिडिटी. ओके यस, दैट द टर्म वाज द फ्लेक्सुरल रिजिडिटी जो वहां पर हमने डिफाइन की थी. इन दिस केस वी विल डिफाइन दिस टर्म एज टॉर्सनल रिजिडिटी. टॉर्सनल रिजिडिटी मीन्स in that case, in case of bending, I define EI. Okay, bending question में क्या define किया था? EI. In this case, we are defining GIP. And obviously, this term GIP is containing more term G, that is a material property, and IP, that is a geometric property. Means more the value of G, more the rigidity shaft. Okay, more the value of IP, more the rigidity shaft. Because you can see here, if this value increases, then the induced theta, that is angle of twist, or twisting will be less in the member. Okay, so this is very important criteria that we are defining here, that is GIP. So means GIP, how can you define GIP? How can you say this one? So GIP, so I'm saying this is TL by theta. Okay, you can say this is TL by theta here. So I'm taking this term here and this term here. So if you want to define or you provide a definition for this one, so what you can say this one? So you can say this one, torsional rigidity will be what? It is required torque or torsional moment, you can say torsional moment to it is the required torsional moment for unit length to produce unit angle of twist. Okay, means it is the required value of torque or torsional moment for a unit length, एक unit length के लिए, to produce the unit twist in the member. So this is how we are defining the GIP. Okay, or torsional rigidity criteria. So this criteria is very important one when we are defining or when you are designing the shaft. Okay, so let's suppose if you want to increase the torsional rigidity of the shaft. okay, but you don't want to change the material. आपको material change नहीं करना. In that case, you can increase the polar moment of inertia of the member. ठीक है, आप सेम मटेरियल का पोलर मोमेंट ऑफ इनर्शिया इंक्रीज कर दीजिए. डेफिनेटली इन दिस केस द ट्विस्टिंग जो आपके पास में उस शाफ्ट में होगी फॉर अ टॉर्क, फॉर अ पर्टिकुलर टॉर्क, दैट विल गोना डिक्रीज हियर. और लेट्स सपोज इफ देयर इज अ स्पेस रिस्ट्रिक्शंस, मींस यू कांट चेंज द डायमीटर and you want to increase the torsional rigidity. In that case, change the material, choose the higher value of G for the material, and definitely you will get the value of torsional rigidity and less the twist in the member. Okay, so this is how this will affect the members for the design purpose. Now one more term, by using this term B equals to C, I want to define it. एक और term मैं define करूँगा. Okay, so मैं define क्या करने जा रहा हूँ आपके इसमें? I am defining very important term, torsional stiffness. Okay, so when we are using the term torsional stiffness, then what is the sense? It is written by small q. Small q से इसको represent करते हैं. Okay, so let's understand this one by the use of spring. So we know for a spring, if I am applying the force F here for a displacement of x, and I want to define the spring stiffness K here, then we know the formula, that is F is equals to Kx. Okay, so here K we are defining the spring stiffness or stiffness of the spring. So in this case, how we are defining? So K you can define this as F by X. Okay, so here F is what? So here F is the required force and X is the displacement. Now for the shaft, when we are using the shaft here, this is shaft here, the shaft here. Now obviously in this case there is no criteria of displacement, but in this case for the applied torque, the displacement will be angular. The displacement will be angular, that we are defining theta here. So to define the torsional stiffness here, that is Q, the required one is the torque here and displacement will be theta here. So this is how we will define the torsional stiffness in case of shaft here. So this formula is defined by T by theta here. Now by using this formula, and from here we want to drive or want to calculate the torsional stiffness. So by manipulating this formula or taking T by theta here, so T by theta here, you can say this is GIP by L here. Okay, GIP by L here. So if you know the material property and if you know the polar moment of inertia, you can easily calculate. You know the length. In that case, without doing any experiment like this one, you can easily calculate that is what will be the torsional stiffness. ठीक है, कि torsional stiffness आपके पास में क्या होने वाली है. So you can calculate by using this formula. ये formula आपके आगे भी काम आएगा in case of mechanical vibrations when we talk about the how the shaft is vibrating or torsional vibrations. Okay, so in torsional vibrations we need to calculate the torsional stiffness of the shaft. Okay, then you will use this formula here to calculating this value here. तो वहां पे भी आपका इसमें काम करेगा. So it's very important formula here. बहुत important formula हमारे पास में आपको याद रखना. And this is very important definition here of torsional rigidity. Okay, so this was the criteria that in that case we are comparing B equals to C. Okay, last one, that term is A equals to C. Okay, छोटी सी बात आपके पास में जल्दी से समझ लेते हैं आपके पास में टर्म है क्या और क्या क्या बिहेवियर रखती है. ठीक है, यहाँ पे एक मिसकंसेप्शन है जो हमें समझना पड़ेगा. So next I'm comparing A equals to C. A equals to C here. So this is tau by R equals to G theta by L here. Now, if you try to write the tau is equals to G theta by L into R. So in this term, everything is okay. We know this is G. Okay, we know this is theta here. We know L here. And we know R here. Radius. But the confusion is what? That is in this formula you will see here that is tau is inversely proportional to L. Okay, tau is inversely proportional to L. Means you will assume if length, you can assume if length increases. So according to this formula, it is suggesting that is the shear stress in the shaft is going to decrease here. So shaft के अंदर shear stress है वो क्या होगा? Decrease करेगा. No, absolutely wrong. ऐसा कुछ नहीं होता आपके पास में. The distribution of shearing stress, that is we define as tau by R equals to T by J or IP. In that case, this term is a constant term here, and we know that tau is directly proportional to R here. Okay, the tau is directly proportional to radius. So over the solid shaft, the distribution of the stress will look like this one. This is a torsional stress here. Okay, that is the tau increases with the radius and max here. Or if you try to draw the distribution over the hollow shaft, okay, if you try to distribute the hollow shaft over the hollow shaft, then in this case, let's suppose this is the Ri and this is the R naught. In that case, the distribution of the stresses will look like this one. Will look like this one. As there is no material inside here, so obviously there is no stresses here. अब कोई stress नहीं हूँ. So this is the max value of stress and this is the minimum value of stress. And you can say that is tau max will be occur at the R naught and tau minimum will be occur at the Ri, or you can take the ratio max by minimum over R naught by R. So this is the suggestion. That is, tau is directly proportional to radius, but this formula is suggesting that is it is also inversely proportional to length. Means if length is minimum, here the stress will be maximum, and when you are moving like this one, in this case the stress is going to decrease. No. Why? You will notice here, that is if you try to check the theta here at this solid part here or this fixed part here, so obviously in this case the theta is 0. But as we are moving along the length, this is length increase कर रही है, ठीक है? In that case the value of theta increases here like this, ठीक है? Theta आपका इसमें increase कर रहा है कुछ ऐसे, okay? Theta increases here, here it is 0 here, here it is very much small here, very much small value here of theta, and its value is increases here like this. It's keep increasing like this one. So in this case, L and theta, so means the term L over theta is actually a constant term, okay? Because as L increases, theta also increases, okay? So as L increases, theta also increases. So this term is a constant term, and you can say this is tau is GR divided by L by theta. So this is a constant term, and for a material, this term is also fixed one. Then from here we can say this is also proportional to the R here, okay? तो यहाँ से भी आप इस R की वैल्यू आराम से आप जो फॉर्मूला है उसको यहाँ से निकाल सकते हैं, okay? So ये कंफ्यूजन यहाँ पे नहीं होना चाहिए. This is inversely proportional to length here. No, this term is actually a fixed one. ये term आपका क्या fixed है? Length increases, theta also increases. Okay, so I think the analysis of this torsional equation now is pretty clear in your mind. अब आप इतने आपका sufficiently आपके पास में इतनी information है that you can solve the problems on this one. Okay, so I think this topic, this analysis is completely covered in this chapter. Okay.